All right, the last four, one, two, 3, 4, 5, the last five. The main thing that I want you to get from these, of course, is the name, the equation, and the picture. There are going to be parts of these that we will have to discuss when we actually start learning the family, but the square root is a different function simply because it actually has a starting point. This one is not very obvious. Let me get rid of that silly square. It's not very obvious on this graph, but it is a starting point. And that starting point is going to be it makes things different for the domain and range. The domain and range is not going to be all real numbers because we had a starting point. And the starting point is going to be that wherever that location is, like in this particular case, it is at 0, 0. This is going to tell me what number goes right here in my domain, and this is going to be what tells me goes right here in my range. So this starts at 0, 0, but it goes forever toward the right. That's why it says x is greater than or equal to 0. Remember, in interval note, that's inequality notation. In interval notation, that means we're starting at 0, but it's going to be a bracket because we are including 0, and we're going to infinity. And same thing for the range. We're starting at 0. But we're going to go to infinity, positive infinity, because the arrow is going up. This arrow is going up. So it's going to go to infinity. Infinity always gets a parentheses. It is starting at the origin, so the x and y intercept is going to be 0, 0. It only is going to cross the x-axis at most once. If I move it down here, it's going to cross this way. It doesn't have to cross it at all. This one up here doesn't cross the x-axis at all. But the most it's going to have is 1. It's not going to swing around and touch it twice. So this in behavior is kind of weird. And again, it's going to change depending on the transformations. But again, all I'm asking you to know is be able to describe the in behavior of the parent function. And this one is only going on the right. It's going up. And that's what this says right here. On the right, it's going up. On the other side, it's not doing anything. It's just stuck at, and I don't know if that means to be, I guess it does. So it's stuck at 0, 0. I wouldn't even put that part at all. I would just put on the right, it's going up, and that would be all I would put. It is continuous, however. Once it starts, you can draw the whole thing without picking up your pencil. All of these are continuous until we get down here to this reciprocal function. Once we hit the reciprocal function, now we have branches. We have a left branch and a right branch. We'll get to that in just a second. The cube root is kind of funky looking. It looks very much like its relative, that cubic function, except this one's going side to side. It is a little bit flatter than it is tall, but here are all of the facts. You should be able to get those copied down, and we will talk about those in detail, but you should be able to understand what each one of them are saying and rewrite these. It's in interval notation right now. You should be able to write it in it's in inequality notation. You should be able to write it in interval notation. In behavior on the right, it's going up. It's going up really slow, but it is going up. On the left, it's going down. And again, it's going down really slow, but it is going down. The reciprocal function is the one that has 2 branches, so it's the first one that's discontinuous. An asymptote is kind of like a boundary line. It's a place where the graph won't go, and in this case, the boundary line is the x and the y axis. I'm not gonna expect you to understand this right now. All I want you to do is know what the graph looks like, be able to name it, and be able to write its equation. I will not call this the reciprocal function. That's not how I learned it. I will call this a rational function. R-A-T-I-O-N-A-L. You should remember from Algebra 1, you learned that rational numbers are defined to be numbers that are fractions. That should make sense then why I call this the rational function, because Where is x? It's in the denominator of a fraction. So this one has an interesting domain and range. They're using, she has written this in what we call set builder notation. In other words, she's saying we're talking about x values. That's what that x value right there is saying. We're talking about x values. That straight line is the symbol for the words such that. And then they're telling you something about the x values. It can't be 0. So basically that's saying it can be any number, x can be any number except 0. The domain contains all numbers except except 0. The way you would write this right here in interval notation, you would need 2 intervals, and the intervals would be negative infinity up to 0, parentheses, parentheses, because 0 is not included on the x-axis. That's where my asymptote is. And then we'll union that together with 0 to positive infinity. And that kind of should also seem to you that we're talking about every number except the number 0. We go all the way up to 0. You see how this branch gets really, really close to the x value 0, but it doesn't ever touch it, and then it jumps across the y-axis, and the x values start to be positive, and they go on forever and ever and ever, but they toward infinity. But it never gets to be 0. So the same thing for the y values. We're going to start at negative infinity, and we're going to go up to 0. We're going to get really, really close to 0, but we're not going to touch it. And then we will union that on the other side of the x-axis, and it's going to go all the way up to 0. So we're talking about y values here, so we're going to be starting down here. This graph right here has an arrow pointing down, so it starts at negative infinity. It goes all the way up. It gets really, really close to the x-axis as we go over here, but it never touches it. Then we jump over the x-axis, run over here to the other side, and these are numbers that are really, really closer to 0, but as we move along these up here, the y values are going to infinity. This particular function, since it doesn't cross the x or the y axis, it doesn't have an x or a y intercept, it is only going to cross the x value one time. It can't cross it any more than that. And this end behavior is really weird too. So on the right side right here, since this graph, since this line is getting closer and closer and closer to the x-axis, we say it approaches 0. Same thing is happening on the other side, on the left side, as the x value goes out toward the left, it is getting closer to 0. Again, don't worry a whole lot about this. We're going to talk about these much more when we study the reciprocal family. I will show you on Desmos and trace it out and all that kind of stuff. It is discontinuous because it is in 2 branches, and the asymptotes are at x equals 0 and y equals 0. The last 2 are exponential and log. Exponential, you can't see it because of this graph is kind of messed up. So let me try to change it to this. It looks kind of like right there that it stops, but it doesn't. It continues to go in this direction. Again, it's just really, really close to the x-axis. It is a solid curve. Oh, I really messed that up. It is a solid curve. And it passes through that ordered pair right there, 0, 1, and 1, 2. The equation is 2 with an exponent of x. That's what makes it exponential. Get all of these down because it has an asymptote as well. An asymptote, remember, is a line that the graph will never cross, and in this case, it's the x-axis, which is the equation y equals 0. That's why on the left side, my graph approaches 0. As I move to the left, my graph approaches 0. As I move to the right, it goes to infinity, so that's kind of normal. Same thing is happening down here on the log function. The log function, you can't really tell, but this log function continues to go along the y-axis right there. It just hugs the y-axis. If you zoomed in right there, and we will, if you zoomed in right there, it'd be getting really, really, really close to the y-axis. It would just never touch it. The equation is super weird for this one. It's literally the word log with an X beside it. Again, I don't expect you to understand that, but I do expect you to know the name. I expect you to be able to recognize that parent function and recognize the graph. All of these little pieces, parts over here, you should be able to associate with the name and the graph.